Okay, we are looking at more examples of quadratic equations, and we're saying, given that the equation y squared plus qy plus q is equal to 0, and also y squared plus my plus q is equal to 0 have a common root, we want to show that this stands. As long as they have a common root, then that stands. So we want to look at the solution. Of course, we are going to say maybe let the common root be what? Be alpha. Let the common root be alpha. That means that common root will be a value of y, such that when you punch y here, when you punch alpha here, this guy goes to 0. When you punch alpha here, that guy goes to 0. So I'm going to substitute for alpha everywhere in the first and the second equation. My first equation, I will have alpha squared plus p alpha plus q is equal to 0. Call this one equation star. Call that one equation star. I'm going to substitute alpha there also, since it is the root. It will also suffice that alpha squared plus m alpha plus k is equal to 0. I'm going to call this one equation star. Now since I have alpha for both, I'm going to start by subtracting. I can subtract equation star minus equation star such that I can eliminate the square of alpha. In that case, I'll have alpha squared plus p alpha plus q is equal to I'm subtracting this minus this. I've said we are getting equation star minus equation star. That's what we are doing. So if I subtract this and this, what do I have? Minus alpha squared plus m alpha plus k. This one is still equal to 0. Because if I subtract this side, even this side, I'll just get 0. I'll just get a 0. So that means the alpha will die. So I'll have p alpha plus q minus m alpha minus k. This one is equal to what? Is equal to 0. I can make alpha the subject of the formula, and I come and punch it here. The reason why I'll come to punch it here is because in my proof there is no alpha. So I can simplify. In that case, I'll have p alpha minus m alpha plus q minus k is equal to 0. And here I'll have alpha into p minus m is equal to, I can bring this one that side. This one will be k, and this one will be a negative. Now it will be minus what? Minus q. I can put that in brackets such that alpha is equal to k minus q out of p minus n. K minus q out of p minus n. I can call this one star 3. Substitute star 3 into star 1. Substitute star 3 into star 1. So I come here where I have alpha squared. I put k minus q squared. I divide by p minus m. Okay, I can just say everything squared. Then plus p alpha, which is actually k minus q out of p minus m, and then plus what? Plus q is equal to 0. When you are proving, keep on referring to where you are going. Keep on referring to where you're going. So in that case, I can try to eliminate the denominator, because in our proof there is no denominator. So in that case, k minus q squared out of p minus m squared. So I'm going to multiply everywhere by p minus m squared. Then plus p into k minus q out of p minus m, still into p minus m squared. Then plus q into p minus m squared. This one is equal to 0 because any number multiplied by 0 remains 0. Therefore, now if we try to cancel, this one will cancel and we remain with k minus q squared. Here, p minus m will cancel once. When it cancels once, we will remain with plus p into k minus q p minus m. P minus m, because one of them has cancelled. Then plus q into p minus m squared. This one is equal to 0. This one is equal to 0. Keep referring to where we are going. In that case, now here p minus m is common. So I can factorize it out. So I'll have k minus q squared plus, that is p minus m into, here we remain with p into k minus q, here we remain with plus q into p minus m. This one is equal to 0. So we'll have k minus q squared plus p minus m into, this one is going to be pk minus pq. This one is going to be qp, but qp is the same as pq, and then minus q what? Minus qm. This one is equal to 0. So we'll have k minus q squared plus p minus m into, this one dies, we'll have pk minus q minus qm. This one is equal to 0. Remember where we are going, we need pk minus mq or qm. Then we also have m minus p. So what happens is I'm going to take this one the other side, such that this is k minus q squared. If I take this one inside, it's going to be a negative minus p minus m into pk minus qm. This one is equal to 8. Yes. So that's what we have. So this negative can enter here and changes this one to m minus p. Then here, remember the question wants q minus k. So I can create a negative, but since it is squared, they are the same. So I can just create a negative and say negative of q minus k squared. This and this are the same. I've removed the negative. Here I enter the negative inside. M becomes positive, p becomes negative into pk minus q what? Minus qm. The negative will die, so I remain with q minus s squared is equal to m minus p into pk minus mq as required. Okay, some people might want to pry into how we have changed this into this, because it might be quite confusing for them. However, when you look at what I have done, I have just pulled out a negative from this bracket. If I pull out the negative, if I return it back, q will be a negative minus q. K will become positive, because negative times negative, that is positive. I have done this to pull out a negative so that I can get q minus k. So that I can get q minus k. So we can simply say q minus k is the negative of k minus q. But since it is squared, the squared kills the negative. So we can say k minus q squared is the same as q minus k squared. Yes. Okay. If the roots of the equation x squared plus 2px plus q is equal to 0. I divide by 8. So that p squared minus 16 is equal to q. Is equal to q. So in this case, I've said the roots of the equation differ by 8. So I can say let the first equation, let the first root be alpha. That means the next root must have a difference of 8 from alpha. So I can call it alpha plus 8. The next root can be alpha plus 8. But what we know is that generally, the general equation, remember we said it is x squared minus sum of roots x and plus product of roots is equal to 0. Comparing this and this, so we can easily know that the sum of roots, which is actually alpha plus 8, so our sum, this one is going to be alpha plus 8. These are first root, these are second root. This one is supposed to be equal to minus, because of the negative, minus 2p. Then for the product, maybe I can use this. The product, I'm having alpha into alpha plus 8. This one will be equal to q. For this one, equation 1. For this one, equation 2. So from equation 1, what do I know? I know that 2 alpha is equal to minus 2p. Minus 2p, then minus what? Minus 8, such that alpha.
Okay.
So we have said 2 alpha plus, we are here. 2 alpha plus 8 is equal to minus 2p. So I brought 2p, 8 to the other side. So I have this. I divide both sides by 2. So here I remain with minus p. Here I remain with 4. So I'm going to substitute this in equation 1, in equation 2. I'm going to substitute that. 2, I know that the alpha squared plus 8 alpha is equal to q. Alpha squared plus 8 alpha is equal to q. So I'm substituting for the value of alpha, because where I'm going there is no alpha, minus p minus 4. So in that case, I have minus p minus 4 squared, then plus 8 into minus p minus 4. This one is equal to q. That one is equal to q. In this case, I am trying to expand the brackets. This is going to be minus p squared, which is p squared. Then minus plus twice the product. And the product is going to be a positive 8p. If I have 2 times minus p, that is minus 2, times 4, that is the positive 8. Then plus the square of minus 4, which is 16. Then this will be minus 8p. And then that will be minus 32. This one is equal to q. That one is equal to q. So the p8p will cancel, and I will have a p squared. 16 minus 32 will be minus 16, and that is equal to q as